So typically, this key stages of image processing can be something like this. You acquire the image and then you subject it to enhancement. You again restore the original image, do some operations called morphological processing, do segmentation. You can, I mean, after segmentation, the idea is to get some representation and description of these objects that you have. Sometimes we call them as feature extractions, right? Now you need to extract some features, then only you'll be able to subject it to object recognition, for example. If it is a face recognition kind of a system, you can input problem domain is face recognition, for example, or gesture recognition, or for example, you're trying to see object detection. For example, you're trying to detect an object in a video, for example. So like a car that is moving, the example that I told you, you're trying to put a bounding box on the um, a particular car or number of cars that are there in front of the vehicle, and you are trying to track them. So when you have to do this, you have to do all these kind of operations, right? So of course, you also have what is called color image processing with the RGB, but RGB you can also have other color combinations. We have certain other color combination formats. Time permits, we'll also look at some of the other formats, but grayscale is the image that we generally use. Grayscale image you has only the intensity to be intensity values are only being intensity values are only being displayed in a grayscale image. You all know, right? So you can have in a typical grayscale image, the values will range from, for example, this is a grayscale image, the value will range from 0 to something like number of levels. If you have k is the number of levels, you can have 2 power k minus 1. Sorry, 2 power k minus 1. So this is the number of values that will be used, for example. So typically a grayscale image will have 0 to 255 as the different values that will pick up. 0 corresponds to black, and 255 corresponds to the white region. So any combination of this, for example, 150 is a region somewhere close to combination of black and white. So you have number of such things that to describe the pixel value. So color image, I told you, you will have RGB. RGB also, for example, if you have an RGB representation, then each is range of values each color will take is 0 to 255. So I told you there are a number of levels. Corresponds to 255 is k equal to 8, meaning there are 8 levels. 8 bits are used to represent these levels. So each one of those colors will take 8 bits. Therefore, in total, to represent 1 pixel, you need 24 bits. So from 8 bits for a monochrome, or it's called monochrome, or sometimes called the grayscale. So monochrome image to a color image, you have to incur 3 times of the. Of course, there are images with more than 24 bits. There are 30 bits images, 36 bits images, and 42 bits of images. There are very fine images with fine colors. For example, you have high definition images. For example, if you form high definition images, then you have to incur more number of bits.